Here we're going to look at another example from section 3.12, conformational analysis of dye-substituted cyclohexanes. And here we've shown a chair representation. And you might notice that if we say this is carbon 1, 2, 3, on carbon 1 we have a bromine, on carbon 3 we have a chlorine. So this is 1-bromo-3-chloro-cyclohexane. And what we want to try to determine if it's cis or trans, it's very difficult to determine if these bromines and chlorines are across from each other or on the same side, up versus down with the chair. So there's two ways that I suggest to do it. One is to also show the hydrogens bonded to those carbons. So for example, on carbon 1, if the bromine is pointing down, it's clearly axial. And so there's also a hydrogen that is equatorial. On carbon 3, the chlorine is pointing away from the ring, not vertical, equatorial. So there must be an axial hydrogen. So one way to think about this is if we have to decide which one is up versus down, the H is clearly down, and that makes the chlorine up. Over here, the bromine is clearly down, making the hydrogen up. And so in looking at this, if the Cl is up and the Br is down, they are across from each other, or trans. If we were to draw this as a flat hexagon, we might say, okay, carbons 1, 2, 3, and we could draw it as bromine pointing down and chlorine pointing up, or alternatively, this might be shown as a wedge for chlorine to mean up and a dashed line for bromine to mean down. Keep in mind that if we drew the flat hexagon like this, this does not tell me if it's cis or trans. This is not good enough to see the stereochemistry, because those bonds, it's not clear if this is up or down, it's not clear if this is up or down. So you need either wedges and dashes or very clear vertical up-down lines if it's the flat shape. With the cyclohexane chair, you really have to look at both the equatorial and the axial positions. Because some of them are easy to see. For example, the axial, it's obvious this is clearly down and this is clearly down.